Hello students, today we are going to take up the topic preparation and manufacture of ammonia and reactions of ammonia along with the uses. So let us start with a very good thought. No one is born happy, but everyone is born with the ability to create happiness. So in our life, we should not miss any moment to create the happiness. So learning outcomes from this session is we will be knowing about the preparation, lab as well as commercial, reactions of ammonia with the oxygen in the presence of catalyst and without catalyst, copper oxide reaction with ammonia, chlorine reaction with ammonia, hydrochloric acid reaction with ammonia, and formation of complexes with copper and usage of ammonia. So let us start. The laboratory preparation ammonia. Ammonia, you know that formula is NH3 and the hybridization is sp3. It is not tetrahedral due to presence of one lone pair. The geometry is tetrahedral, but the shape actually is pyramidal due to presence of one lone pair, which decreases the angle from 109.5 to 107 degree. And because it is having one lone pair, therefore it acts as Lewis base. So now comes to the lab preparation of ammonia. Ammonium chloride on reacted with NaOH give rise to NaCl, water and ammonia. Similar reaction can be done with calcium hydroxide, which is more preferred as compared to sodium hydroxide, and magnesium nitride. I would like to repeat, magnesium nitride plus water, that is steam relatedly, and magnesium hydroxide and ammonia is formed. So these are the methods in the lab preparation of ammonia. And if you talk of commercial method, that is Haber's process, flow diagram is there on your slide here. We are adding nitrogen and hydrogen. If you see from here, nitrogen and hydrogen being added and it is compressed to increase the pressure. We know that high pressure is required for the reaction. And once this high pressure gas is coming here in the chamber containing the catalyst, which is iron oxide powder, and along with aluminium oxide, and K2O is there, which is acting as a promoter. And this product, ammonia, is formed, and some products like unreacted nitrogen and hydrogen also will be there. So how to remove that? We are condensing that gas, we are cooling that gas, the ammonia will become liquid, and the unreacted gas will go back and we can pump back into the system. So this is the recycling of unreacted gas. Why this need? Because the efficiency is very less. Because efficiency is nearly 10 to 15%. Therefore, we need to recover the gas. And what is the ratio of nitrogen hydrogen used is, if you see here, is 1:3, as from the equation also the same thing. And you know that nitrogen, how we are getting nitrogen? We are getting from liquefaction. Okay, distillation. Fractional distillation we say. Hydrogen we are getting from Bosch process, and the temperature is 700 Kelvin, so roughly it is 450 to 550 degrees Celsius, and it is 2 atmosphere, 200 atmosphere. 200 means 1 atmosphere is equal to 10 per 5 Pascal. 200 into 10 per 5 Pascal. So or we can say 20 megapascal. Mega stands for 6, and this is delta is negative 92.4 kilojoule per mole. It means the action is exothermic. As per Le Chatelier's principle, to get the maximum yield of ammonia, we need to increase the pressure, because you see the number of moles of the products, that is 2, and number of moles of reactant is 4. Delta N is negative, so therefore the pressure should be high and temperature should be low. While temperature 700 is maintained to initiate the reaction. Once the reaction is started there and the heat will produce, then we have to extract the heat, we have to remove the heat, so that temperature is maintained at 700 Kelvin. And catalyst increases the rate of reaction, and promoter is used as molybdenum or Al2O3, and K2O is also used for that, and which is increasing the efficiency of the catalyst. Okay, so now next comes here, it is the reaction of ammonia with oxygen. And if you see the two reactions, in first reaction, ammonia is the oxygen, when reacted with oxygen give rise to nitrogen and water. But when the same reaction, same reactants is reacted in the presence of catalyst, platinum, rhodium, and or in the copper in the lab, so what is going to happen is NO gas is formed. So this way we should be very careful that which question is asked, accordingly you have to answer. Similarly, reaction of copper oxide to ammonia. See here, copper oxide is changed to copper, which means reduction, loss of oxygen takes place, and ammonia is what is happening? Ammonia is losing hydrogen, it means oxidation. So it means ammonia is acting as a reducing agent and copper oxide is oxidizing agent. Okay. So this way, so which property is explained here? Ammonia as a reducing agent property is used in this reaction. And you know that color, copper oxide is black in color and red copper is reddish brown in color, metal. And next comes to the reaction of ammonia with chlorine. Ammonia with chlorine excess. Please do distinguish these two reactions. Ammonia, chlorine is excess and ammonia is in excess and chlorine is less. So if the quantity chlorine is excess, you will get the yellow oily liquid, and which is also explosive in nature, nitrogen trichloride, and hydrogen chloride we will get in the gaseous form. Similarly, if you are using ammonia as in the excess, so ammonium chloride and nitrogen gas will be formed. So these two reactions, so this by part also we can write that ammonia plus chlorine in the same manner, N2 plus HCl, then ammonia again reacted with HCl to give ammonium chloride. So the product by final reaction is this. So you need to remember the final reactions are these two. If chlorine is in excess, NCl3 will be formed along with HCl. If ammonia is in excess, ammonium chloride plus nitrogen will be formed. And you know the reaction with HCl is very simple. Dense white fumes of ammonium chloride will be formed. Okay, which is sublimable substance. Now, reaction of ammonia with copper to form copper complex. You know that copper, we cannot store ammonia with copper. Why? Because it dissolves copper. It is forming soluble complex. Which complex? This complex, CuNH3,4. If copper ions, for example, copper sulfate solution is there, when you are passing ammonia through that, or when you are treating with ammonium hydroxide, what is going to happen is deep blue color will be formed. And that deep blue color is due to formation of the complex, which is soluble complex. Okay. So how it is formed? Because you know that ammonia is a ligand here. Ligand is what? Ligand is lone pair donor. So lone pair donor is forming which bond? Coordinate bond. Coordinate bond is formed with what? Central metal atom. Which is central metal atom? Copper. Okay. So these small things are there. More you will study in the chapter complex compounds or coordinate chemistry. Okay. Nitrogen atom in ammonia molecule has a lone pair of electrons. The molecule possesses strong tendency to donate this lone pair of electron and act as a ligand, which donates 2 electrons to form coordinate bond between ammonia and the d orbitals of copper. Thereby the complex formation, this is the theory behind the complex formation, where copper is central metal atom, ammonia is a ligand, and ammonia is forming the bonds with the copper. Copper is having d orbital, therefore the bonds are formed, and this complex is soluble and therefore deep blue. And one more question can be relatedly asked from this particular topic or heading is that why we can't store ammonia in copper tubes, so copper vessels. And this is the answer for that, because ammonia can dissolve copper, so that's why that leakage can take place. Okay, so that's why we cannot use copper as metal for storing ammonia. Okay, now next is physical properties. It's colorless, it's less dense than air, means lighter than air, and alkaline gas, and you know lone pair of electron is there, Lewis base, pungent smell, very soluble in water. Why it is soluble? Because of intermolecular hydrogen bonding. And ammonia, you know that it's a polar molecule. Why a polar molecule? Because nitrogen hydrogen bond is polar. And why it is polar? Because the difference in the electronegativity. Nitrogen is more electronegative than hydrogen. That's the reason. And normally the gaseous state, it exists at room temperature. And when you increase the pressure, the gas will change to liquid or further to solid, depends upon the temperature and pressure. And it is a weak base because it can donate lone pair of electron. Ammonia plus water give rise to ammonium ions and hydroxyl ions. A substance giving hydroxyl ion will act as a base. Extremely soluble in water due to intermolecular hydrogen bonding with water. So next comes to the uses. You know that medicine, cosmetics, because it is used as a bleaching agent also, refrigerant, industry, and preservative we are using, transport, and medical, metal treatment, lab reagent, solvent, cleanser. So fertilizer industry, petroleum industry, mining, rubber, paper, leather, these finds use of ammonia. Okay. Next is the summary for what we have discussed so far. We have discussed the lab preparation of ammonia, in which we have discussed that ammonium solvent treated with sodium hydroxide or calcium hydroxide, we are getting the gas ammonia, or we can treat stream or hot water with magnesium nitride or aluminum nitride. Similarly, commercial method is Haber's process, where temperature should be low, pressure should be high for favoring a high yield of ammonia as per Leach-Chatelet principle, and the catalyst used is finely divided iron, and the promoter is molybdenum or K2O plus Al2O3 also can be used. Reaction of ammonia with oxygen in the absence of catalyst gives N2, and whereas in the presence of catalyst platinum it gave rise to nitric oxide. This reaction is the base for the preparation of nitric acid by Ostwald process. On treating ammonia with copper oxide, black color of copper oxide changes to reddish brown metallic copper. Ammonia reaction with excessive chlorine gives NCl3, which is yellow explosive liquid, and hydrogen chloride, where in excess of ammonia when treated with chlorine gave rise to ammonium chloride and nitrogen as main product. Ammonia formed deep blue tetramine copper complex with copper due to formation of coordinate bond between the ligand, that is ammonia, and the center beta atom, that is copper. Okay, because copper is having d orbitals, which thereby it can accept the lone pair of electron from ammonia, forming the coordinate bond. Ammonia is widely used in the preparation of fertilizer, refrigerant, and cleansing agent. So let us check the knowledge what we have gained. The process from which ammonia and nitric acid is produced. And you might be knowing that ammonia is produced by Haber's process and the nitric acid is produced by Ostwald process. Second question is yield of ammonia in the Haber process. Yield of ammonia is only 10 to 15%. And ammonia is highly soluble in water due to formation of bonds. Which type of bond it is? With water is intermolecular hydrogen bonding with water. Okay. So the next question here it is. Name the yellow product formed when ammonia is treated with chlorine and excess. So what you will be getting? Nitrogen trichloride. Okay. And similarly, name the color of the precipitate formed when ammonia solution is treated with ferrous chloride and ferric chloride is dirty green, reddish brown with ferrous and ferric salt respectively. So if you have find the correct answers, a lot of congratulations to you. You have done a very good job. And let us repeat the thought. No one is born happy, but everyone is born with the ability to create happiness. So because why these three stones has been shown here, this stone says I am smaller than this, but this stone say I am larger than both of it. So this is always, instead of doing comparison, we should be uniquely representing that I am better than this. So everybody is having unique ability, unique stance, so we have to enjoy that. Okay, thank you.